Okay, so let's take a look at the practice problems on page 383. Question number 17. A newspaper is held 6 centimeters from a convex lens. So DO is 6 centimeters. From a convex lens that has a focal length of 20 centimeters. So F is 20 centimeters. Find the image distance, so you want DI. So 1 over F is equal to 1 over DO plus 1 over DI. So 1 over DI is equal to 1 over F minus 1 over DO. 1 over DI is equal to 1 over 20 centimeters minus 1 over 6 centimeters. Common denominator is 60, so 3 over 60 minus 10 over 60, which is 7 over 60 negative. Flip 60 divided by 7, negative 8.571 centimeters, where of course the negative means virtual. Number 18. A magnifying glass has a focal length of 12 centimeters. F is 12 centimeters. A coin 2 centimeters in diameter, so imagine the coin standing up on its edge. The 2 centimeters in diameter then would be the height, HO, 2 centimeters. Is placed 3.4 centimeters from the lens. DO, 3.4 centimeters. And it wants to know what is the location, which is DI, and what is the diameter, which is HI. So first, DI. 1 over F equals 1 over DO plus 1 over DI. So 1 over DI is equal to 1 over F minus 1 over DO. 1 over 12 minus 1 over 3.4. Common denominator, 402, 204. It was right order in my head, I swear. 204. 12 goes into 204 17 times. 3.4 goes into 204 60 times. 43. So negative 43 over 204. Flip negative 204 over 43. Divide negative 4.744 centimeters. Again, where the negative here means virtual. All right, and then HI. Remember, hi-ho, di-do, it's off to work we go, with the negative there. So negative DI-HO over DO. So negative, negative, that's going to become a positive 4.744. HO was 2 centimeters. DO was 3.4 centimeters. Do the math and get 2.791 centimeters. Works out to be positive because it is erect. Right? If it was negative, it would be inverted, but because it's virtual, it's erect, so it works out to be positive. So when there's a negative on the DI, it means virtual. When there's a negative on the HI, it means inverted, which means it's real. Number 19. A stamp collector wants to magnify images by 4. So it wants M to equal 4. When the object is placed 3.5 centimeters from the lens. 3.5 centimeters. What must the focal length be? So first we can get HI. So negative first we can get DI. Negative DI over DO. So DI is going to equal negative M times DO. So DI is going to equal negative 4 times 3.5, 714. So DI equals 14 centimeters. So then once you have that, then 1 over F is equal to 1 over DO plus 1 over DI. So 1 over 3.5 plus 1 over negative 14. Common denominator is 14, so 4 over 14 minus 1 over 14, which is about 3 over 14. Flip, divide, 14 over 3, so 4.6 repeating, I believe. Okay, positive, because it's a convex lens. If you want to make get a virtual image that is bigger, you have to use a convex lens, which would have a positive f. If you used a concave lens, your image would be tinier, and the f would be negative, just like it is for a diverging mirror. Number 20. Suppose you are looking at a stamp through a magnifying glass and want to increase the size of the image. So you want to make HI bigger, okay? So you want it to go up. Should you move the glass closer to the stamp or further away? So think about the lens. You're using it as a magnifying glass, which means your object is going to be between f and the lens, okay? And you want HI to be bigger, and HI will be bigger when DI is bigger, because remember HI over HO is equal to DI over DO. So if we can get DI bigger, then HI will be bigger. So if we look at 1 over F is equal to 1 over DO plus 1 over DI, then DI is equal to 1 over F minus 1 over DO. So DI will be biggest when 1 over DI is tiniest, and 1 over DI will be tiniest when these two fractions are really close to each other. So the closer that DO gets to F, the smaller this difference here will become. And the smaller this difference becomes, then the bigger DI will become. Okay, so what should you do? You should move the object towards F. Is there a limit? Yeah, F is the limit. If you get to F, there's going to be no image, because then the difference will become 0, and you can't do 1 over 0 to find DI. Okay, so move your object out to F, but don't put it right at F. Get it as close as possible. All right, now let's go to page 389. And we're starting with number 12. And number 12 says the focal length of a convex lens is 17 centimeters. And the object is placed 34 centimeters in front of the lens. Make a ray diagram to find out the location of the image. Hopefully, you can see where the image is going to be, right? Because here's F, 17 centimeters, and here's the object at 2F. And if the object is at 2F, then the image should end up over here at 2F. So a ray going in parallel to the principal axis is going to get reflected in such a way as to come out through F. A ray passing through O is going to go straight through in parallel to the principal axis, comes out through F, in through O. Here's my head, here's my feet. Both of them are at 2F, but on opposite sides of the lens. Number 13. Convex lens of a copy machine has a focal length of 25 centimeters. Letter to be copied is placed 40 centimeters away. First part of the question, where should the paper be? In other words, what's DI? So 1 over F is equal to 1 over DO plus 1 over DI. 1 over DI, 1 over F minus 1 over DO. 1 over 25 minus 1 over 40. Common denominator, 200. So for 8 over 200 minus 5 over 200. So 3 over 200. So DI should be equal to 200 over 3, 66.6 repeating is DI. Second part of the question wants to know how much will it enlarge